I have this problem. So I have an x on both sides of my equal sign. So first thing I've got to do, add the 7. Because my whole goal is to get rid of the radical. So I have this right here, x plus 9, and then over here I get x plus 7. So to get rid of the radical, I'm going to put both sides in parentheses, and I'm going to square it. So over here I get x plus 9, and over here you get x plus 7 squared. Well, I need to remember that x plus 7 squared is the same thing as going x plus 7 times x plus 7. So if I multiply stuff out, you'll get these values. Okay, and then pull them back down. Okay, so that's the same thing as going x plus 7 times x plus 7. So here we go. I get x plus 9, and when I multiply those together, which I've showed up in the box, I get x squared plus 14x, add 49. Okay, you guys, this ends up being a quadratic, so I just have to go through and use all my zero solving skills that we developed through polynomials. I minus x from both sides, minus 9. I just want to go get it equal to 0. Minus x, minus 9. So then I get this. 0 is equal to x squared. Add 13x, add 40. Okay, beautiful thing, right? Set equal to 0. I check to see if it factors. What will multiply to 40? Well, 1 and 40, 2 and 20, 4 and 10, 5 and 8. And then I start to repeat myself. 5 and 8 will give me 13. So this factors into x plus 5 and x plus 8. So when I solve for the zeros then, when I solve, I get x is equal to a negative 5 and x is equal to a negative 8. But both of those cannot be legit solutions. So I'm going to plug and chug to check. So if I plug in negative 5, negative 5 plus 9, that gives me a value of 4. Square root of 4 is 2. 2 minus 7 is equal to a negative 5. So that could be that's a real solution. So I do have an extraneous one. So let's come over here and let's check our negative 8. So when I plug that in, negative 8 plus 9 gives me 1. The square root of 1 is 1. 1 minus 7 gives me a negative 6, and that is not 8. So x equals a negative 8 is an extraneous solution. Okay, so when I graph both sides of the equation, they have one intersection, and it's at that x value of negative 5, so they both match. The extraneous solution comes from when I have a negative and it comes down here, so it would touch here at a negative 8, but that's not part of my real solution.